Okay, the following is a video over special right triangles and some problems that are on your homework. So I'm going to kind of show you how I work through these. Um, One of the things I want you to see here is that, it's just that it gives us a right triangle, gives us an angle measure and a side length, and tells us to find x. Now, one thing I want to show you is that given something like this, you always want to draw a picture if you see that you have a special right triangle. Now, when I see this, I see I have a right angle. If I know that one of these angles is 45 degrees, then I also know that this angle is 45 degrees. Okay, you can we know that just from knowing about the sums of interior triangles, or sums of the angles of a triangle. And then, because both of these angles are congruent, then these sides are congruent. Okay, and then if the side lengths are L and L, then this side length here is L times the square root of 2. Okay, so if I look at this picture, I can answer that question. I can solve for x using this picture. Okay, now the idea here is that I've got this angle measure is 45 degrees and this is 90. That means that this angle measure has to be 45 degrees. Okay, so since these two angles are congruent, then these two segments are congruent. Okay, and if this is 14, if the length of this segment is 14, then the length of this segment is 14. And so this is a isosceles right triangle with side lengths of 14. So then because of that, I can then simply say that x is just 14 times the square root of 2. Okay, and that follows what I'm doing here, that this is length L, the hypotenuse is L times the square root of 2. These legs are 14, so my hypotenuse is 14 times the square root of 2. So this is how we do these types of problems, okay? Now over here we've got something different, okay? And this is a little weird. So over here on this example, um, I've got a 45-degree angle here, so that I can then just automatically say that's 45. And so those are congruent. That means that these two segments are congruent. So then I've got a problem though, is that I've been given my hypotenuse and it doesn't have this little square root of 2 in here. But here's what we know, okay? This triangle is proportional to this triangle. So we can kind of set up an equation here. And here's what I do. Given a 45, 45, 90 triangle, I always write that my legs are L, and that this is L, and that this length is L times the square root of 2. Okay, every time. Now what I can do is I can actually set up an equation here, and I can say that, well, L times the square root of 2 is equal to 45. Okay, I can then also write the equation that x is equal to L. So if I solve for L, I can actually find out what x is, okay? And I have that here, okay? I have L times the square root of 2 is equal to 45. So then I could divide each side by the square root of 2 and actually solve for L. And so what I end up getting is I get L is equal to 45 divided by the square root of 2. But we have a problem with this. And the problem is that we actually don't like to write numbers with square roots in our denominator. So the trick to simplify those is to actually multiply the numerator and denominator by the square root of 2. Okay? So I end up getting this. I end up getting 45 times the square root of 2 being divided by it. If I'm multiplying two radicals, I can just multiply the numbers underneath, and I'll end up getting the square root of 4. Well, the square root of 4 we can simplify, and we end up getting that L is equal to 45 times the square root of 2 over 2. Okay, and so that's what that length is. Now, since L equals that, we know x is equal to L. So then I can come here and I can then say that x is equal to 45 times the square root of 2 all over 2. Okay, and that's kind of a strange answer to you, but that's a number. I'm taking the number 45 times the square root of 2, I get a number, and I divide by 2. Now, the reality is, guys, is that this is exact. This is an exact measurement. Okay, if you were to plug that into your calculator and hit enter and get a decimal, that would be an approximate. But we're looking for an exact answer. Okay, and this is something that we need to practice. All right, you'll see this. These ones are really easy, but these ones are kind of tricky. But I always set up my equation. Okay, so now let's do the same thing, but let's do it for a 30, 60, 90 triangle. Now, these are problem 7 and 8 from your homework. What I want to do real quick is to just sketch a quick graph or quick picture of a 30, 60, 90 triangle. So if this is a 90-degree angle, we'll call this length S. Remember that this is S, or I'm sorry, 2 times S. Okay, and then this length down here was S times the square root of 3. Now, my small angle down here is 30 degrees. Okay, and my big angle up here is 60 degrees. So this is a picture that you guys really should know how to draw and know what to do. So, but I'm going to apply this picture to each of these problems. So if this is 30 and 90, the resulting angle here is going to be 60 degrees. Do the same thing over here. I'm going to call this 60, and then this has to be 30 degrees. Okay. Now, what I'm going to do over here is I'm actually going to put in these values for S, 2S, and S times the square root of 3. So I'm going to call this S, I'm going to call this 2S, and I'm going to call this S times the square root of 3. Okay? Now I can set up all these different equations. Basically what I know is that 9 is equal to S. Okay? I can then say that my value for X is equal to 2 times S. Okay? And then I can say that Y is equal to S times the square root of 3. Now, it may look kind of confusing to as to what I'm doing, but I'm just setting up these equations. I know what S is, so I'm going to plug that in to each of these and find what X and Y are. So I can simply just go here and say, well, X is equal to 2 times 9, if S is equal to 9, and then I get X is equal to 18. Oh, so is 18 double 9? Does that seem right? Does that follow what we had in our picture? It sure does. So now I want to take 9 and plug it into S over here, and I'm going to get Y is equal to 9 times the square root of 3. And so that follows this whole relationship as to this length is 9, this length is doubled 9, and then this length is 9 times the square root of 3. Okay, and those are your answers. All right. Now, in number 8, this one's a little bit different. The picture is backwards, and you've got to understand that I can rotate this, I can flip it around, I can do whatever I want to it, but it's still going to have that same shape, and it's still going to be similar to this triangle, okay? So now here I'm going to do the same thing now. Uh-oh, we got a problem. That this is S, this is 2S, and that this is S times the square root of 3, okay? So we've got an issue here, okay? This one is really not a friendly one. Okay, now one thing that I know is that 2 times S is equal to 4 divided by the square root of 3. Okay, now I also know this, that Y is simply just equal to S. So if I find out what S is, I can figure out what Y is. And then I know that X is equal to S times the square root of 3. So once again, if I can solve for S, then I can plug it in here and find out what X is. So what I'm going to do here is solve for S. And in order to solve for S, I'd want to divide both sides by 2. So then S is going to equal 4 times the square root of 3 all over 2. Now the interesting thing here is that 4 and 2 can divide out. And that divides 4 over 2 is to 2 over 1. So I end up getting this. I end up getting that S is equal to 2 times the square root of 3. Okay? So now, because I have a value for S, I can take this and I can plug it in for my thing for Y and my equation for X. So I know simply that Y over here is equal to just 2 times the square root of 3. Okay? And that's pretty easy. Once I find what S is, I can just plug this in. Over here, it's a little bit trickier. So I'm going to say X is equal to S. Now, S is 2 times the square root of 3. 2 times the square root of 3 times the square root of 3. And so I end up getting this. I end up getting X is equal to 2 times the square root of 9. Now I got 9 by taking 3 times 3. Since they're both under the radical, that's a property that I can do. And so then I get this. I get x is equal to 2 times, well, the square root of 9 is just 3, so x is equal to 6. 2 times 3. Okay? So that's not as easily as seen, as that one's not as easy to see. That one's kind of tricky. But again, guys, I'm doing the same thing. I'm just doing, you can see here that this is doubled. Okay, 2 times the square root of 3, I multiply that by 2, I get 4 root 3. And then we did some math over here to find that x was equal to 6. Okay, so this is what you're going to need to do, this type of work for these types of problems. Again, all I'm doing is using my picture, plotting those values for what I have, and then setting up a series of equations and solving for x and solving for y once I find what s is. Now, simplifying these radicals and doing all this kind of stuff, that takes a little bit of practice, but you guys can do that. Okay, I do want to go over one word problem real quick. Guys, these are pretty easy if you just actually read through them and maybe draw a picture and give it a shot. So it tells me that I have a square piece of paper. Well, I have a square piece of paper. I'm going to draw a square. Okay, and it tells me that it's 150 millimeters on each side. So this is 150 millimeters. Okay, this is 150 millimeters. All right, and so on and so forth. But what we end up doing is it says it is folded in half along a diagonal. Okay, so if I take this and imagine that that's a straight line, let me fix that. That was just terrible. We're going to cut along this diagonal here. There we go. That's a lot better. Then the result is a 45, 45, 90 triangle, and I agree. So if I bisect a square, these two angles are congruent, these two sides are congruent, I have a 45, 45, 90 triangle. What is the length of the hypotenuse? Well, remember, in a 45, 45, 90 triangle, dear Lord. All right, let's just draw a quick picture that these two are congruent. I have a right angle. This is L, L, L root 2. So all I know is that this is L, and this is L root 2. So then I just automatically know that my diagonal here is just going to be 150 times the square root of 2 millimeters. Okay, and this is not a problem I don't think that you guys are incapable of doing. You're capable of doing it, but you just need to read through, draw a picture, and put down what you know. Okay, so I hope this helps.